Okay, this is number 17, and we're supposed to solve it by elimination. Elimination means you're going to get rid of either the x's or the y's by adding the two equations together, and you want one, either the x's or the y's, to have opposite coefficients. All right, so the coefficients on the x's are 1 and 1. I mean, that's a 1, that's a 1. And the coefficients on y are -1 and +1. So the y terms are already opposites, so you can add the two equations together. X plus x is 2x. -y plus +y is 0, so it's gone. The y's are gone. 1 plus -3 is -2. You want to find out what x is, you'll have to divide by 2, because x is being multiplied by 2, so you divide by 2 to make those 2's cancel. So x equals -2/2, which is -1. Now you're going to go back and find out what y is. You can take that -1 and plug it into either equation to find out what y is. I'm going to put it back into the first equation. So x, which is -1, minus y equals 1. All right, so I need to get the y by itself, so I'm going to add 1 to both sides of the equation. So I'm going to have left over on this side, I'm going to have -y equals 2. Therefore, if -y equals 2, +y equals -2. I'm multiplying both sides of that equation by -1 to get y by itself. Y equals -2. So the answer to that problem is the point, and it has to be in parentheses with a comma, -1 for x and -2 for y. That's it. And you can go back and check that this actually works in the equations. Check it in the first one. -1 for x minus -2 for y. That's supposed to equal 1. -1 minus -2 is -1 plus +2, which is 1. And that's what it's supposed to be. So that works. Plug it into the second equation. -1 for x plus -2 for y is supposed to equal -3. -1 plus -2 does equal -3. So this is the correct answer. It works in both equations. Always check it. All right, looking at number 18. Now you're supposed to solve by substitution. Substitution is when you solve for one of the terms, one of the variables, and you plug it back in, you substitute it for that variable in the other equation. All right, so these are your two equations, and you want to solve for one of the variables. It doesn't matter which one you solve for. I'm going to solve for the y in the second equation. So I'm going to subtract 2x on both sides of that equation, and if I do that, the y is left by itself on the left side, and on the right side I'm going to have 5 minus 2x. So I subtracted 2x on both sides. That's what y is. Y is this. So now I can take that quantity and substitute it in for y in the first equation. That's why this is called substitution, because I'm going to substitute it. All right, so x plus 3y, so 3 times 5 minus 2x, because that's what y is. That's supposed to equal -5. Now I use the distributive property. 3 times 5 is 15. 3 times -2 is minus 6x, equals -5. Now I can combine my x's, so I'm going to have 15 minus 5x is equal to -5. Now I can subtract 15 on both sides, so I can get the x's by themselves on one side. -5x equals -20. Divide by -5 on both sides to get that x by itself. So x equals -4. All right, to find out what y is, I can take that -4 and plug it back in anywhere I want to. I'll plug it in right here. So y is supposed to equal 5 minus 2x, and x is negative 4. So 5 minus negative 8 is 5 plus positive 8, so 13 for y. That's what y is. So if y is 13 and x is negative 4, I made a mistake. All right, so number 18, we're supposed to solve this by substitution. Substitution is when you solve for one of the variables, either x or y, in one of the equations, and then you substitute that amount back into the other equation for that variable. So you have these two equations, x plus 3y equals negative 5, and 2x plus y equals 5. And you can solve for x or y in one of the equations. I'm going to solve for x in the first equation. To do that, I'll subtract 3y on both sides of that equation. So when I do that, I will have x left on the left side, and on the right, I'll have negative 5 minus 3y. So I just solved for x in the first equation, and now I'm going to take that amount that I got for x, and I'm going to plug it in for x into the second equation. I'm going to substitute that amount into the second equation. So the second equation is 2x. So now instead of x, I'm going to put this amount, because that's what x is, and then plus y equals 5. Now I'm going to distribute the 2, so negative 10 minus 6y plus y equals 5. All right, now I am going to combine my like terms. So negative 10, negative 6y, or minus 6y plus 1y will be minus 5y. And that's supposed to equal 5. I need to get the y's on one side, everything else on the other side. So I add 10 to both sides. So I'll have negative 5y equals 15. And divide both sides by negative 5. So that will cancel, and you get y equals negative 3. Now I'm going to go back and figure out what x is. I can plug that y value into the first equation, the second equation, or over here where I solved for x. So I will do that. X equals negative 5 minus 3 times y, which we found out is negative 3. So x equals negative 5 plus 9, which is 4. So the answer is 4, negative 3. In parentheses, with a comma, x comes first, y comes second. And you can go back and check that this actually works in both equations. If you look at the first equation, it would be 4 minus 9 equals negative 5. If you look at the second equation, it would be 8 minus 3 equals 5. So it definitely works in both equations. Number 19. You're supposed to circle the rational numbers. Here are the numbers listed. You've got 2 squared root of 3, you've got pi, you've got 7, you've got 4/9, and you've got negative 2.3 with repeating. These are the rational numbers. Any number that can be written as a fraction with an integer in the numerator and an integer in the denominator is a rational number. 2 squared root of 3 cannot be written that way. Pi cannot be written that way. But 7 can be written as 7 over 1, so that's rational. 4/9 is already written as a fraction with an integer in the numerator and an integer in the denominator. Negative 2.3 repeating is negative 2 1/3, because that's what 0.333333 is. And so you could write that as negative 7/3. So that is a fraction with an integer in the numerator and an integer in the denominator. 2 squared root of 3 and pi are non-repeating, non-terminating decimals. That's what an irrational number is. It cannot be written as a fraction with an integer in the numerator and an integer in the denominator. Anything that can be written with an integer in the numerator and an integer in the denominator is going to be either a decimal that ends, that stops, or it's going to be a repeating decimal. But these two guys are non-repeating, so they don't repeat in a pattern. If you punch them into the calculator, you will get a non-repeating, non-terminating decimal. That's irrational. Can't be written as a fraction. All right, the next one has true or false. It says that the natural numbers are a subset of the irrationals. Natural numbers are not irrational. The natural numbers are 1, 2, 3, 4, 5, and so on. They are not irrational. They can all be written as fractions. 2 over 1, 3 over 1, 4 over 1. They are not irrational, so that is false. All right, the next one says that the integers are a subset of the rationals, and that's true. All integers are rational numbers, so that's true. All right, that's it. Make sure that you have gone over these problems until you know how to do them before you take that test.